A heated metal ball is dropped into a liquid. As the ball cools, its temperature T degrees Celsius T minutes after it enters the liquid is given by T equals 400 e to the minus 0.05 T plus 25. Part A, find the temperature of the ball as it enters the liquid. So that's telling me that the time is 0. So if I substitute that into the formula, I'll get 400 e to the minus 0.05 times 0 plus 25. The minus 0.05 times 0 is going to be 0. E to the power 0 is just 1, which when multiplied by the 400 is 400, plus the 25 is 425. So that's my answer for part A. Part B. Find the value of T for which capital T, the temperature, is 300, giving your answer to 3 significant figures. So let's make our T 300 here. So 300 equals 400 e to the minus 0.05 T plus 25. So we'll first subtract the 25 from both sides. So the 300 take away the 25 is 275. And we'll then divide both sides by the 400. We can now take logarithms of both sides. So on the left-hand side, I've got ln. On the right-hand side, I've got ln. So we'll get ln of 275 over 400. ln of e to the power, our inverse operations, they're going to cancel out to give me minus 0.05t. And I'm then going to divide both sides by the minus 0.05t. So the ln 275 over 400 divided by the minus 0.05 gives me t as 7.49. And that's in minutes. Part C finds the rate at which the temperature of the ball is decreasing at the instant when T is 50. Give your answer in degrees Celsius per minute to 3 significant figures. So rate is telling me to differentiate. So I want to differentiate this. So I'd get dt by dt. Now differentiating the exponential. Now the exponential stays as being the exponential, but I do have to multiply by the coefficient of the t. I have to multiply by this minus 0.05. So we have to have that at the front. The 25, when I differentiate that, will just be 0. So actually this is just my expression. The minus 0.05 times 400 gives me minus 20. All I need to do now is to substitute 50 in to find the actual value when t is 50. And when I do that, I get minus 1.64. So that's the dt by dt value. The question's actually asking me for the rate at which the temperature of the ball is decreasing though. So if I gave my answer as minus 1.64, that would be me telling the examiner that I think it's decreasing at minus 1.64. And I don't think it's decreasing at minus 1.64 because that would mean decreasing by a negative would actually mean it's increasing. So it's not decreasing at minus 1.64. It's decreasing at 1.64 degrees Celsius per minute. That's what it's decreasing by. The minus here is just telling me it's decreasing. The examiner already knows it's decreasing. They've said it here. Minor detail, but it should be given as a positive there because the negative is implied in the question. Right, part D. From the equation for the temperature, T, in terms of T, given above, explain why the temperature of the ball can never fall to 20 degrees. So let me just write out that equation again. Why does this equation mean that the ball can never fall to 20 degrees? Well, let's have a look at the bit that changes, the exponential here. I know that e to the power of minus something, minus anything, it doesn't really matter what I write here. I know that that will tend towards 0 as t tends towards infinity, as it gets a really big number. And I know that by looking at the graph. The graph goes like this. Gets closer and closer and closer and closer and closer to 0, but never actually touches it as t gets large values. Therefore, when I times that by 400, t would be 400 times 0, which is 0 plus 25. So T would tend towards 25 degrees Celsius as T tends towards infinity. Therefore, it can never fall below 25 degrees Celsius and can never reach 20.